Hello everyone and welcome to week 11 of Math 2. Here's some examples from MyMathLab. So I chose question number 2 because this part in here looks like they chopped something off. I don't know. So express a function of x with just one variable x. In other words, at first we're going to have x and y on the picture, but then we're going to be able to create a function with just x. So they're talking about a rectangle, and the length is x and the width is y, which also means that this side is going to be y and this side is going to be x since it's a rectangle. And then for the perimeter, that means add up all of the sides. So the perimeter would be, well, there's two x's and there's two y's. So there would be two x's plus two y's. And that does take care of the perimeter part, but it doesn't take care of the one variable part. That is where the 215 comes in. And that's talking about area, and when you have a rectangle, area just means multiply the two sides. So if you multiply the two sides, that gives you area, and they say that that equals a 215. And then over here we can solve for y, so just find a red pen and say divide this side by x and divide this side by x, so that y equals a 215 divided by x. And then I can take that and substitute it in for y over here. And now that it's going to be a function of x, I can call it f of x. So f of x equals the 2x plus 2 times, and then in place of y, we use this, 215 over x. And then I'm just going to simplify it a little bit. So 2x and then 2 times 15, well, that would be 400 if you double it, and that would be 30. So plus 430 divided by x. And then if we wanted to find the maximum, just take the derivative and set it equal to 0. So the derivative of 2x would just be 2. And then I view this as just like 1 over x, and the derivative of 1 over x is negative 1 over x squared. And the 430 can just sit there patiently, and there's the derivative. When you set this equal to 0, you can take this negative and move it to the other side. So if I set it equal to 0, I would take this and move it to the left side. It would become a positive 430 divided by x squared equals a 2. And then I could multiply by x squared to move it to this side and divide by 2 to move the 2 to the left side. So then I would have 430 gets divided by 2, and then that equals x squared. And then just take the square root of both sides, and the square root of, so that's a good time to use a red pen, square root, square root. The square root of 430 divided by 2 is x equals a 14.663. And then you can just take that, substitute it in right there, and you would know what y equals. So this one, I did this extra work even though basically right here they were asking for the f of x, and that was done right here. But most likely after you do that, they're going to say, then find the derivative and then do all of this. And the next one is, so this is what it looks like when they show me all of the parts. And this is number 5 from the homework. And it says that they sell X cell phones per week. And this is the demand function. So basically this is how many cell phones per week people want to buy. So basically at the best, they're buying 400 per week, and then minus this 0.1. So Next up, what price should they charge, and also how many phones to maximize the revenue? So the revenue is equal to how many cell phones do they sell, and then times the price. And the price is this one over here. Oh, just a moment ago I said that was 400 cell phones. That's $400. These are pretty cheap cell phones. Anyway, so it is the number of cell phones times the price. And the price function is 400 minus a 0.1x. And then I would even multiply that out. So distribute the x. There would be 400 minus x. And then minus the 0.1, and x times x will be x squared. And then to find the maximum, that's where you set the derivative equal to 0. So the derivative is going to be 400, because the derivative of x is 1. The derivative of this is 2x. When you move the 2 in front, it's going to make it 0.1 times 2, so that's 0.2x. And then set the derivative equal to 0. And I would take this negative term and move it to the other side so it becomes a positive 0.2x equals 400. And then just divide, so it's going to be 400 divided by 0.2. And what is that? So a 400 divided by 0.2 is 2,000. And the x stands for how many cell phones they sell per week. Because when I saw that 2,000, I was like, what? They're charging $2,000 for a cell phone? What are they, Apple? But no, that's how many they're selling. So this is their sales. So 2,000 in sales. And then if I take that and substitute it in here, so then the price will be 400 minus the 0.1 times x, and then substitute the 2,000 for x. So that's going to be 400 minus a 0.1 times 2,000. And then that's going to be $200. So those, what are those, like flip phones? $200 a piece? Burner phones, pretty cheap, $200. Definitely not Apple. So the company should produce 2,000 cell phones each week at a price of $200. All right, that's that part. And then the maximum revenue would be, just go back to this function before I took the derivative and substitute that the x is 2,000. So if I substitute the x equals 2,000 right here, so here's the x equals 2,000, and then substitute it. So 400 times 2,000 minus a 0.1 times 2,000 squared. And so that is, let me see, there would be a comma right here. That would be $400,000. I wish I got paid $400,000 a week. Well, I decided to be a teacher, so it's my own fault. All right, next, what if they want to maximize their profit? So then profit profit is going to be their revenue. In other words, how much do they bring in? And then minus the cost. So profit is going to be the revenue function, which is this one. And then minus the cost, which is this one. So profit equals the revenue, which is 400x minus the 0.1x squared, and then subtract this function. So then subtract the 20,000 and plus 135x. So basically you would then take this function, take the derivative, so basically like I did over here, take the derivative set equal to 0, and then get that final answer. Okay, then another one that I want to do is number 7. So this is number 7. And I did an example like this in the video lecture. Hopefully you watched that. Mine was about soda. And this is about sandwiches. So it says that, so I'm going to let x equal the price and y equal the sandwiches. And then I could even make a little table like this and keep track of the information. So they say when the price is $4, then they sell 320 sandwiches. Seems like it's getting washed out. Okay, that didn't really help. Hold on. Sorry. Okay, there we go. Okay, next, a market survey shows that for every 10-cent reduction, so in other words, if they reduce this to $3.90, so they reduce it by 10 cents, they're going to sell 40 more sandwiches. So if they sell 40 more, this is now 360. And then we could find the slope. So it looks like I need to adjust it again. Sorry, what's happening is there's a window next to me and the sun is going in and out of the clouds. That's why it's getting light, dark, light, dark. Okay, the next thing is find the slope. So if you subtract the two y values, 360 minus 320, and then subtract the two x values, $3.90 minus 4, on top, that's going to be the 40. And on bottom, that's going to be a negative 0.10 cents. And then when you divide those, so then take a 40 divided by a negative 0.10, and it's negative 400. All right, then find the equation of the line. And I'm going to use these two. So I can then go y minus the y value of 320 equals the slope times x minus the x value of 4. And then simplify this. So on the right side, there would be negative 400 times x, and then negative times negative will be positive. I know that 4 times 4 is 16, and then just add on a couple extra zeros. And then add 320 to both sides. And when I add 320, it's going to say negative 400 times x plus 1920. All right. Then maximize revenue. So revenue. Basically, if you multiply $4 per sandwich times 320 sandwiches, that's how much money they're going to make. And I need to adjust it again. So if you multiply the x and y, that's revenue. So multiply revenue equals x times y. And then we just found out what y equals, so substitute that in. So revenue equals x times the negative 400x plus the 1920. And before taking the derivative, I would multiply it out. That way I don't have to do the product rule. So if you distribute the x, it's going to be negative 400 x squared plus 1920 times x. And then the derivative. So bring the power down and multiply. That's going to be negative 800. And the derivative of 1920x is just 1920. And then once you have that set equal to 0, you can take this negative term, move it to the left side. It becomes a positive 800x equals 1920. And then I just need to divide both sides by 800. So divide by 800, divide by 800, x equals the 1920 divided by 800. 1920 divided by 800 is 2.4. And if you go back to right there, x is the price, and so the price should be 2.4, which when you convert that to money is $2.40. $2.40 for a sandwich? Sounds like 1973 or something like that. Okay, so the deli should charge $2.40 per sandwich. And then they basically have you go, they just change the numbers and have you go through the same thing again. If they change it to 20 cents, and then 5 more sandwiches would be sold. But basically the work would be the same. And so I just want to set this one up. Although I did do one like this in the lecture, mine was just slightly different because I said there was a brick house or brick wall, so they didn't have to build the whole rectangle. But it's basically the same. So there's this rectangular enclosure. Mine was a pig pen, but just got a rectangular enclosure. And then that means that these two sides, I could call them X, and these two sides, I could call them Y. If you happen to switch and call these two the Y and these two the X, at the end you get the same answer. So 3 of the sides, it costs $6. So I'm going to say this is $6, this is $6, and this is $6. And then the 4th side costs $18 per foot. So perhaps that side has to have a gate built into it, so it costs more. And if you decided you were going to put the 18 over here and this 6 over here, at the end, you're going to get the same answer. The math understands it. Okay, so that's the setup. And then the area has to be 1250. So that means just area equals x times y. And then it has to equal 1250. And then we use this to solve for y, so divide both sides by x. And then that's what y equals. And then I just leave that one alone for now because they said find the dimensions that the most economical fence, that means find the minimum amount of money. So for the money or the cost, it's going to be, there's a 6x and a 6x, so that's 12x's. And then there's a 6y and an 18y, so these two together are 24y. And then that's where we use this in place of y. So this y is going to get replaced with this fraction. So the cost equals a 12x plus 24 times 1250 divided by x. And then I want to see what is 24 times 1250. So that is a 30,000. So the cost equals 12x plus 30,000 divided by x. And then this is going to be very similar to the very first example that I just did in this video. So I'm not going to do the whole thing, but the derivative would be, this would be 12 for the derivative. This is just like 1 over x, and the derivative of that is negative 1 over x squared. And then the 30,000 stays there. And then you can just move this to the other side so it becomes positive and finish just like I did over here on the very first example. The steps are going to be exactly the same. And then suddenly there's this algebra problem. And the reason for this is when you find an antiderivative, so if you have something like the derivative equals x to the 7, then in order to find the antiderivative, you would add 1 to that, which is going to be an 8, and then divide by 8. And so that means that the original function y was x to the 8 over 8, and then you put a plus c at the end, and it's done. But when I started, it had to be x raised to just one number. Well, that's the reason for this, because if this was what the derivative equals, then I need to simplify it so it looks more like this in black before I did the red part. So for one thing, I can make this into 2 fractions. So when you're dividing by a single item, then you can just say, well, the first one gets divided by 7 and then the cube root of x. And for the cube root, I'm going to rewrite it as x to the 1/3. But that's the same thing as this. And this denominator has to be the exact same thing. And then for the numerator, you just break it into 2 pieces. And you say this one. Now this means 1/3 power, and this means that it's squared. So that basically means that instead of being a 1/3, it's going to be a 2/3. So this is going to be x to the 2/3. And now I'm done with this. And now just go over to the plus 7. And then I still need to simplify your answer. So in here, when you have division, then you actually subtract the exponents. And a 2/3 minus a 1/3 is a 1/3. So that's going to be x to the 1/3. And the 7 has nowhere to go, so it just stays there. On this one, the 7s can cancel. But then I'm going to rewrite this one so that it is just x to a number. So that would be x to the negative 1/3. So then if we were finding the antiderivative, you would just add 1 to the exponent and divide by that number, add 1 to the exponent and divide by that number. This one was just asking for the algebra part, so they were just asking for that part. And then I just wanted to do one more. So there's a lot of basic antiderivatives between number 13 and number 34. But this one is worded a little bit differently, so I wanted to show you what's going on. So basically it's saying this is the derivative, what's the original function? So this one, the single x, is like having x to the 1. And for a constant 4, you could rewrite it as 4 times 1. And since x to the 0 equals 1, that's the same thing as the original minus 4. Then add 1 to the exponent, so this becomes a 2, and then divide by that 2. For this one, add 1 to the exponent, so that becomes x to the 1, and then divide by that number, so divide by 1. So that means that the original function y is, well, over here, these 2's are actually going to cancel, so all I have is x squared, or x to the 2. And then minus 4, and then this is just x to the 1, or just x. And then don't forget, they all have a plus c at the end. Now we need to find c. So this part right here is basically just telling you, plug in that x is a 4 and y is a 5, and then you could solve for c. So y is a 5, x is a 4, and then we can solve for c. And I can see, I can see that this is 16 minus 16, so these two actually cancel each other out. And that means c equals 5. So then my final answer, that I can't squeeze into this little box right here, but my final answer would be y equals the x squared minus 4x, and then the 5, there we go. And on this I don't have to put y equals because they already did that right there. Okay, that's it for today.